Today we are going to talk about one another concept which is in Abinitio, which is called component folding. So whenever we talk about performance improvement in the given graph, so uh, along with other different options to tune the graph, there is one more concept in Abinitio which is called component folding. So we know that there are multiple ways the ab initio can is performing well with in terms of data processing. First is like there are different data parallelism, so it can process the data parallelly in different way, three kind of ways, right? Pipeline data parallelism, pipeline parallelism, and component parallelism. So that is one way of improving the performance of the certain graph. But what is component folding? So there is a concept in ab initio which says that to minimize the number of processes running or applying for a particular data processing. So whenever we talk about any batch graph or a continuous graph, whether it is in a multi-way or uh, a straight way in the sense of whether it is a serial process or it's a parallel process or a multi-way processing. So when we talk about any component within a graph, so there is a certain process would be created in ab initio. So if I talk about filter by expression, right? So this component itself is a separate process. Reformat also is in a separate process, and rollup itself is in a separate process. If the process is multi-way, then those many number of let's say if you four ways, then four filter by expression process would be created. Similarly, four reformat process would be created if it is in a four way. And if the layout of the rollup is four way, then four rollup process would be created whenever the processing of this graph happens. So this is the uh, this we shall know. I mean, we should know about it, right? So if you look at this graph, so let's say we are processing n way parallel, or output is also n way parallel, right? And this data is passing through filter by expression, reformat, and rollup. So n number of filter by expression processing would be created, and there would be n number of reformat process, separate process would be created, and n number of rollup process depending upon the for each partition one process, one each component. So this way you can remember, right? If it is a serial, then only one process would be created for a filter by expression, right? So so the component folding is a way to minimize the number of processes to to achieve the same result. We If we could minimize the process, right? So what if I tell you, right? So if these are all component can process simultaneously, right? So if I say that these can combined in a way that we can minimize you know the total memory consumption by this setup. Okay, so currently we have n process of reformat, n process of rollup, and n process of filter by action. Total 3 n processes would be created if this is a normal setup. If I can say that, if you can combine the respective partitions of these three graphs, right? And I can say that this is the n way folded, you know, n way folded, process, and folded. Let's say this is folded, right? If I could say like this, so we can fold all these three components together to make a one process, right? To make it a one process for all these three component, and each partition will have one process, right? So we can say that total process would be how many? N process. We can reduce the process number of processes by 1 by 3 we can do by 1/3. Total process is N only. So it will work in a way that this is a same single component basically, and there are N partitions on top of that, therefore N processes, so that we can minimize the total number of process. So if any record is getting processed by this component, this super component, I should say, folded component, if any record is getting processed, so it will come out from this folded component if everything is getting processed for that particular record. So let's say my first record is getting into the filter by expression in this end. So after processing everything, it will come out from this one. Then only second process, second record would be start processing. Okay, and then second will come out, and then third will get start processing like that. So this is the component folding. Okay, so if we look at the concepts, right, component folding, why we need component? We understood that what is the component folding, why we need it for resource conservation, especially memory actually. So we know that if we fold these components together to make a one, so total memory requirement would be reduced because the number of processes are getting reduced by 1/3. So the 1/3 resources we are using, and we are producing the same result. Therefore, we are conserving the resources, specifically memory. So if you have less number of process, everything will be reduced, like CPU cycles and or other overhead, right? They can also be reduced if we have less number of process. Then streamlining the process. We know that. So this we know that this is a single component. So we can streamline the process. We can say that yeah, this whole thing will happen. We have an input. This whole thing will happen as a separate process, let's say, and then there will be an output. We can streamline everything and so improve the startup time. So startup time, the overall startup time would be reduced. So whenever because it's in one unit, so there are no separate process are getting in the startup time, the separate process would be would kick off, right? Kick off in the sense of they will be in active mode, right? Whenever we run the graph, so all those processes will be come into active until and unless those processes come into active. That time is called a startup time. So the process when we click on the run button, and the time when it starts executing is the startup time. So because we have less number of process to be to become active, so therefore we can reduce the startup time basically. So these are the three benefit we are targeting to achieve in this whenever we fold any number of components, right? So what is the prerequisite? We cannot fold anything else, anything and everything, and also it is not advisable or recommended approach. So okay, first of all I will tell you, right? So it always not necessary, you know to the component folding may not improve the overall computation time or overall memory consumption. It may not, but that is the part of testing and observation, or depending upon the use case wherein it can fit, right? So in further, if I talk about what is the prerequisite of foldable components, so there are components which cannot be foldable or which are not advisable to be folded, right? So there are certain rules wherein we can think of any number of components to make foldable, right? There are foldable components, there are not foldable components. So these should be in the same phase. Okay, so if I have these processes are running in another phase and this is running in some other phase, we have a phase break over here, you cannot fold these three, right? So that is one thing. Okay. So if you have, in the separate phases, if you have phase break over here, you cannot, this one, you cannot fold these three. You can fold these two if you have phase break here, but you cannot fold all these three. Okay. Now we have a same layout. I told you, right? So these all are processing in the n-way parallel. So these are all filter by expression, reformat, rollup, all are processing in the n-way parallel in the sense of, let's say, 8-way parallel. So these are all are 8-way layout for all these components. So therefore we can fold. Otherwise, if you have any partition component over here and these are processing in 2-way and these are in 4-way, right? You cannot fold that. So if this, you cannot fold all these three. You can fold if it is 4-way. If it is 4-way, both if they are 4-way, then you can fold these two only. You cannot include this, which is in another layout, right? So this is the prerequisite to make the graph foldable. So this must be fed from same origin component. In the sense of, if this folded the whole superset of these components, I mean folded component, if it is getting fed into the same, same origin component. So my origin component is input, input file. So if it is feeding, if it is receiving the data, right, this component is receiving the data from the same source, then only you can, make it for, you can fold it. If this is receiving another, let's say we have another, let's say another input file, right, and this reformat is we have an, receiving the data like this, then you cannot fold it. Okay. So you cannot fold all three. We have to have the single source of, data feed. Same origin must be there. Okay. So next point is must be foldable unlike unsorted join. So these component must be foldable. So like filter by expression, reformat, concatenate, rollup, call web service, you know, read JSON, right? These components are, foldable. So these all the components, whenever you are folding, these should be foldable components. So if we have unsorted join, right? I said unsorted join. Unsorted join is like, if you insert an unsorted join over here, right? Let's say it is we are, inserting any unsorted join over here. So we will not, see the benefit of, folding, because this will be holding up the records basically. It will hold up all the record. There will be a buffering, a lot of buffering in unsorted join. If you have sorted join, that is fine. If you have unsorted join, sorted join, whenever key processing is complete, it will be outputting the record. But in case of unsorted, it will buffer everything and then only it will decide all the groups and then it will pass to the rollup. So therefore, if the particular component is, buffering the inputs, then you cannot, you can, you will not be see the benefit of, folding, component folding. So you can, you can remove the, you cannot, you avoid this, concept of folding the your components connected by straight flow. So these are the, straight flow. All these components are using the straight flow. Okay, there should not be any, parallel or this, fan in, fan out, or these kind of flows are not if so. This will be the straight flow, because if your input layout and output layout is same, then only it will be a straight flow. So that is the concept actually. Basically it is saying that this should process in the same layout, or this itself is a, like, this point and this layout point, they are same basically in with respect to the ultimate, requirement. So these are the prerequisite, and now let's see example. What are the examples? So when we can use it actually. So first of all, if we have a less number of records to be processed, that is one thing. If you have a lot of records are need to be processed, a lot of sorting is involved, a lot of unsorted joins or maybe unsorted roll up, if these kind of processes are there, a lot of records are there, then it may not be, there won't be a visible performance improvement in the when you do the component folding, right? So so in this process even there are micrographs, right? So these are the transactional graphs actually. So the request come from the web, it do some little small transaction in the, let us say, database, or it will retrieve the data, or maybe it will update the data and then it will go back to the web, that response. So if these kind of small graph are there, so those are called micrographs actually. They run, everything is in the same page, everything in the same layout. They are very there are less number of, because there will be one request coming in and it will be getting processed within a seconds, and everything is finished, the graph run is finished. And so if these kind of requirements are there, these kind of processing we are involving, so the component folding is, so therefore the by default micrographs are, you know they are component folded, their component folding are involved in this micrographs. And the transaction group, so transaction group will be highly connected with respect to the inter-process communication. So whenever any transaction comes, so let's say we have a sequence of process on a particular transaction or particular record. Let's say we are doing some data retrieval for a particular record, and then we are doing some update in the database for certain number of records, and therefore another is insertion and update. So these kind of, let's say, three components in sequence, right? So if that kind of, so in what happens in transaction group is, they are, they abide by ACID properties, atomicity, integrity, and those kind of the database referential integrity concept will be applied. So if that is the setup, we will talk about the transaction group in separate video. So what are the transaction group and how they works actually. So for now, you can say that it's a kind of a micrographs. So one request comes and it passes through certain 2 to 3 different database components. Do first this one and then this one and this one, right? So that all the three consecutive process is called a transaction group. That should happen or not happen, like it should be atomic, the transaction should be atomic, therefore this is called a transaction group. And everything happens in a one shot. So these kind of requirements are they are inbuilt of this one component folding. So the micrographs and transaction folding, these are the main examples actually, which they are already using. But in our case, if you want to try to set up the particular component is foldable, so we can, first of all, we should be setting the graph settings. So we will go to the settings in the main main toolbox, go to the graph settings. There is, and we have a script option, and we can say that there is a checkbox called fold components, we can check it. Okay, then your graph is all the components. Then you can set up the you can try to fold the components within that graph, right? So okay, and then what are the benefits of it actually? Okay, less number of processes save overall startup time or memory consumption, right? So we have talked about already, because we are reducing the number of processes required to complete the graph processing. So therefore there is a benefit of it actually, because there are less number of process, less number of resource required, right? And the time scheduling overhead also, because if we don't have multiple process, we are reducing the number of processes, so there will be a scheduling thing, and everything else will be reduced. Therefore the overall benefit actually, less inter process communication. So these are the, now when I fold it, these component becomes really very connected. So if one record is getting processed by filter by expression, so it will eventually pass to reformat and roll up. So all the, so because it's in one process, so the inter-process communication, in the sense of uh, the the process which communicates, right, from the filter by expression and reformat, these will be reduced actually, right? So the input output also would be reduced. So what are the drawbacks? So loss of pipeline parallelism. So if I told you, right, so whenever first record is processed, if it processed by every component within the folded setup, then only it will be output. Otherwise, if it is not folded, so this, first record is getting processed by this one, second is getting, let's say, processed by reformat, third is getting processed by filter by extraction simultaneously. So that is called a pipeline parallelism. But whenever you fold it, so as soon as the first record is getting processed by every process, all those within all these process, then only second, record will be taken into the process. Okay, until so that's therefore it is reducing the pipeline parallelism in a way. Okay, and internal buffering. So there is one more thing I told you, right? So if we have a lot of internal buffering involved, you know, then it is not advisable to use the this one. You know, so if you have a lot of buffering involved in the sense of components called unsorted join or unsorted roll up, right? These kind of or the sort component, right? And the sort within groups component. So these kind of components, may involve the internal buffering. And anyway, the component is going to wait for the data. So why to fold it actually? So let it process separately, right? If the reformat is holding up the records, right? It is not giving the record to the roll up, then it's not advisable to make all these in folded. Otherwise, let the different component process in their different respective respective flow and respective normal graph. Okay, so we will talk about this micrograph and subgraph. So there are linked embedded subgraph, linked subgraph, and dynamic subgraph, right? So how the component folding is applied for here? So the embedded subgraph will inherit the folding. So before we come to the different subgraphs, let's see. I mean, what different setups can be done in folding. So if can I fold these components? Can I fold this component? Let's say I want fold this. Let's see the principle of component folding. What is the prerequisite actually? Same layout, same phase, same layout, let's say, same phase, let's say, must be fed from same origin. Yeah, it is feeding from same origin. Must be foldable unlike unsorted join. Yeah, these are not unsorted join kind of components. Yeah, these are, okay, connected by straight flow. Yeah, these are such, this is straight, and this is straight, right? This is straight, and this is also straight. So this is eligible for the component folding. This kind of setup. We have one component here, the second and third and all, right? These are processing fed the data. It's kind of pipe component parallelism, right? So now let's talk about another setup. So can I fold this? I cannot fold it because it is not satisfying the same phase, same layout. Let's say same phase, let's say same layout. Okay, must be fed from same origin. Yeah, this is the not satisfied. Third point is not satisfied, right? This one. So therefore, it is not foldable. Let's see the next setup. So next setup is, can I fold this? Yes, I can fold it because all of these are in same component, same phase, same layout, straight flow. Also feeding from the same origin. Yes, we are feeding in the same origin, right? So we can fold it. Connected by straight flow. Yes, we can fold it. See this one. Can I fold everything? No, because we are feeding the this is process feeding from the different, right? So these kind of we need to take care actually. So if we talk about uh, let's say this graph is in the these two components are in the subgraph, embedded subgraph. Okay, so how the folding will be decided? So by default, the we can override the folding from the parent graph. Parent graph in the this graph. This is subgraph, right? This is subgraph. If you say it like this is within the subgraph, right? So the folding will be inherited by the this one. Folding will be inherited by the folding of this embedded subgraph would be inherited from the outside, or it can be independently can be folded. If there is no folding applied over outside, so it can be. Or what you can do, you can include this. Let's say this is a subgraph, this is my another component, this is my another component. So you can fold, the component, all these components. Is that right? So this everything, this everything you can include in the folding subs folding. You can make it foldable group. This is foldable group, including embedded. Okay, this can be done, right? So let's talk about what is the different. So I was talking about, right? So there are other different, graphs, subgraphs, linked subgraph, embedded subgraph, and the dynamic subgraphs. The linked and dynamic subgraph also inherit the properties from the parent. So you cannot override actually. They by default inherit, but in embedded you can override. Okay, but these linked and dynamic will follow the folding setup by the parent graph. So how you can, so let's say this is a flow, right? So you can, whenever you right click, you can see the, when I need to apply the allow to component to be folded or not. So there is an option when you right click on the, flow, you will have option allow component folding or disallow component folding, right? So that you can select, and you can disable the folding for a certain component if you don't need it actually. Let's say in between there is another component which has a lot of, internal buffering and, data buffering. So you want to, exclude that component. You can go ahead and, you can right click on the flow which is connected to this one. You can, exclude this, right? So this is the concept of component folding actually. So we are going to see multiple miscellaneous concepts in the times to come. Please subscribe my channel. Thank you so much.